If you're like me, you've probably played many roguelike games and have wondered how to create so many items and effects that all seem to react to different things. It seems like a monumental amount of work at first, but today let's go through how to set up items and equipment in your game that are easy to create and can react to any event you want. And this starts by creating an abstract class. What is an abstract class? Well, one way to think of them is as a template class that can be used to create other classes that all behave in the same way, which will allow us to call the same function on many different scripts but have them all react to that call differently. If you've spent time creating scripts in Unity, you've probably already seen this idea in action with monobehavior. If this sounds intimidating, don't worry, it'll make much more sense as we go along. So first thing we want to do is create a new script called item, and we want to remove everything related to monobehavior, so the start and update methods and the derives from monobehavior tag on the class. Next we want to put in square brackets above the script system.serializable. This will let us see the class or any class deriving from it in the inspector when used as a reference, because by default, abstract classes cannot be viewed in the inspector. Let's also give our class the abstract tag. Now let's create one of those shared methods. Let's create a public virtual void method and let's just call it update, and let's pass in a script that handles our player stats. In this project it's just simply called player, and an integer called stacks, which will be useful a bit later. Now this virtual keyword is important. It will allow us to override this method in our items that we create, giving us the ability to create unique code for each of them while calling the same update method. Another keyword you can use is abstract, like our class up here. The difference is that an abstract method must be created in each class that derives from the base class, while a virtual method can be ignored if wanted and will default to the base class if not overridden. And we want our items to be able to give their name, so let's create an abstract string method called giveName. And because it has the abstract keyword, this will make sure that we have to give a unique name for each item. Now let's create a simple healing item. Now you could do this in a completely new script if you wanted, but I like to have all of my items in the same place, so I'll be making it just under our item class. So let's create a new public class called something creative like healing item, and just like monobehavior, let's put in :item to say this class derives from our base item class. Now we will immediately be getting an error saying that this class does not implement an inherited abstract member. That's our abstract versus virtual keyword in action. So let's put in our giveName method, and we will need to change the abstract keyword to override. This will give a new error saying that this method must have a body, so let's add one. We need to return a name, so let's just return our fancy name. Now we no longer have an error because our update method uses the virtual keyword, but having an item that just says its name is not very useful, so let's implement an override for our update method. Remove the base autofill, and let's have this item heal the player every time the update method is called. In this project, our player script has a health variable to track our player health. So let's put in player.health plus equals 5, and this will increase our player's health by 5 every time our update method is called. So now we have an item. Now we need a way for our player to hold our items, so let's look into creating an item list for our player, and the first thing we need to make is a list script. So let's create a new script, let's call it item list, and again let's remove everything to do with monobehavior and add system.serializable in square brackets. Now the script will be used to hold some information for us, namely the item in question, its name, and how many of the item we have, called stacks or stack size or count or any name that makes sense to you. In this project it will just be called stacks. Now for our info storage to work, we need to create a new method to set our variables. Underneath, let's create a new public method called itemList and pass in a new item, a new name, and a new stacks. Now in the body of the method, let's set item as new item, name as new name, and stacks as new stacks. And then let's save our script. Now over in our player script, let's add in our list reference. So let's put in a public list that is of item list. And let's just call it items. And we need to make sure that it equals a new list of item list with open and close parentheses. Now down in the start method, let's add an item to our list to see it working. The first thing we need to do is create a new instance of our healing item, and we do that by making a local variable of healing item, and let's just call it item, equals a new healing item with open and close parentheses. Now let's add this to our list by typing list.add, new item list, and then pass in our item we just made a copy of. For its name, let's just put in item.giveName with open and close parentheses. This calls our giveName method we just created in our item, so it will return its name. And then let's set its stacks to 1. Now if we hit play and look at our player script, we can see our item being added to our list, but our health is not increasing, and this is because we are not calling the update method on our items yet, so let's set that up now. Back in our player script, in the update method, let's set up a for each loop, and this loop will be for each item list I in items. We will call its update method, so i.itemUpdate, and inside we need to pass in a player script, so let's just use this to pass in our script. And then we need to pass in a stacks count, which we're keeping track of in our list, so let's pass in I stacks. Now this will work just fine, and it will cause the update method of our items to work just like the update method of our player script here, But if you have many different items with complex code in their update method, the performance of your game could take a hit. So let's see how we could also do this with a coroutine. So below update, let's put in an enumerator, call item update. Then let's just Control X and Control V our for each loop. Now to stagger how often our update is called, let's put in a yield return new wait for seconds, and let's wait for 1 second. You could also wait for less than 1 second if you wanted your items to update faster, but 1 second should be fine for our items. Then we need to start a new loop. So we need to start coroutine, and the coroutine will be call item update, and now our coroutine will loop. But we need something to start our coroutine in the first place, so in the start method, let's do a start coroutine call item update to start the loop. Now if we hit play and look at our script, we can see our healing item is now increasing the player's health by 5 every second. But if you remember back in our healing item, we are just simply increasing our player's health by 5 and not accounting for our stacks variable. Let's fix that by instead increasing the player's health by 3 and then an additional 2 per stack of the item. Now with 1 stack, the player's health increases like 5 just like before, but if we add another stack onto our item, it increases by 7. And then another, and it increases by 9. Now that we have the basics down, let's create something a bit more fun. Let's make an item that gives us some extra fire damage on hit. So let's create a new method in our base class called onHit. And then let's require a player script, an enemy script, and a stacks amount. Now that we have the method we want, let's create our item. So down below our healing item, let's put public class fire damage item to keep with our creative naming scheme, and also have it derived from our item class. Let's again override the giveName function and return the name we want. Now let's override the onHit method, and let's decrease the health of the enemy script we pass into our method by whatever we want. I think a fire damage item should be a bit more linear in its scaling, so let's just deal 10 damage per stack. But just like our update method, we need to call onHit, so back in our player script, under our call item update coroutine, let's put in a new function. So let's put public void call item onHit, and let's pass in an enemy script. Then let's just copy our for each loop again, but let's change the update call to onHit. onHit requires an enemy script, so let's just pass along our enemy script. Now let's say we have a basic hitbox script that checks if it touches an object tagged as an enemy and then does some damage. Let's also call our player call item onHit function and pass the enemy we just collided with. Now when we hit an enemy with our hitbox, we will also call all items onHit method on that enemy. Now back in our player script, let's just change that item that's added in our start function for testing over to our new item. Let's also start with 2 stacks to see our stacking damage. And if we hit play and look at our list, now we have 2 of our fire damage item. And if we go hit some enemies, we can now see we are doing some additional damage. So now you may be thinking, well, this is great for shifting values around, but what if I want to spawn a prefab? Well, we can't just drop a prefab into a reference like we normally would because our scripts are instantiated at runtime. So how do we get a prefab reference? We can use a handy function called resources.load. To use this function, we need to create a resources folder. Any folder you create in the assets folder, named resources, will become a resources folder and can be used by resources.load. But before you go and put all of your prefabs into a resources folder, you should know that all assets in a resources folder are loaded into memory at runtime, because Unity must assume that any assets in the resource folder will need to be used at any time. So you should only put assets in a resource folder that are used often and at random, like item effects. So inside our prefabs folder, let's create a new folder called resources. And then inside of our resources folder, let's create a new folder called item effects. So let's say we created this cool healing area effect, and for some reason we think it would be a good idea to make an item that spawns these under our player whenever they jump. Let's take our healing area effect and place it inside the items effects folder that is located inside our resources folder, and we need to remember this directory. Now let's create our item. Let's create a new method called onJump and pass in a player script and a stacks number. Let's collapse our other items to make some room, and then let's make our new item. And let's again override our giveName function, and then override our new onJump method. Then let's create a GameObject reference. In our onJump method, let's check if our reference is null, and if it is, let's use resources.load to set our prefab. So let's put effect equals GameObject in parentheses, resources.load. And now we need to give the directory as a string. Resources.load assumes we are looking in a resources folder, so we only need to finish the directory with the files inside of our resources folder, and finally the prefab itself. And then at the end we need to put type of game object. Now we just instantiate our game object just like we would instantiate any other prefab. But just in case we want to alter anything about our effect, let's instantiate it as a local variable, so let's put game object healing area equals game object dot instantiate. The name of our reference, so effect, and let's set its position to our player. And let's set its rotation to 0 in all axis, and an easy way to do this is quaternion.euler vector3 0. Now we need to call this new method, so let's repeat what we did in our player script by creating a new function called callItemOnJump. Copy our for each loop and change the method to onJump and only pass in our player script and our stacks count. Now, where we handle all our jumping code, let's just add callItemOnJump now. Now if we hop in our game and start jumping around, we can now spawn our healing area. But we can end up spawning a lot of our prefab, so why don't we also set up a cooldown on our item. Back in our healing area item, let's put in a new float variable called internal cooldown. Then let's override our update method. Get rid of the base update, and then since we know our update is called once per second, we can just reduce our internal cooldown variable by 1 per update. If you call the update function faster than once per second, you'll have to adjust the amount reduced appropriately. Now down in our onJump, let's wrap our prefab instantiate code in an if statement, checking if the internal cooldown is less or equal to 0. And if it is, let's run the code and set the internal cooldown to whatever you would like, and in this case, let's just go with 10 seconds. Now if we run our game and start hopping around, we can see our item spawns once and then only spawns again after 10 seconds. So now that we have a few items, how do we get them to the player? Well, let's start with an item pickup script. So firstly, we need a way to choose which item to drop. We can't just use a reference at the top because our items derive from an abstract class. So we need a way to choose which items to drop and then have our script give that item based on that choice. So let's use an enumerator and switch statement. If you've never used an enumerator before, it's basically a way to assign numbers to a list of words. And it has two benefits for us. It will give us a nice drop-down menu to choose which item we want to drop, and second, it works with a switch statement, which can be used to assign the correct item script to our reference. So let's first set up our enumerator. At the bottom of our script, let's just put public enum items. Then in the body, let's list the names of our items using a comma to separate each name. Now if we hover over our names, we can see that each one is assigned a number starting from 0 going upwards. Now at the top, let's put two references. The first being the item we want to drop, so let's put public item and name it item. Next we need a reference using the enumerator we just created, so public items, and let's name it item drop. Now let's create a function that will assign our item based on our enumerator choice. So let's put public item, so it returns an item, assign item, and let's pass in our enumerator to use called item to assign. Then in the body, let's make our switch statement. If you've never used a switch statement before, it's easiest to think of it as a super if statement, where instead of using a boolean to decide to execute some code or not, we use an integer to decide which code to execute. And remember, our enumerator is basically just a list of integers. So let's build this by putting switch, and then in parentheses, let's use our item to assign. Now the switch statement will expect a list of cases that are assigned to an integer, or we can just use our enumerator as an integer. So let's put case items.healing item, and then a colon. Underneath, we'll need to return a new healing item. And then just repeat this for all of our items. Once we're finished, we will still have an error in our function, and this is because all code paths must return an item since our function has a return type of item. And to fix this, we need to assign the default case of our switch statement, in case none of the above integers are true, which we will just default to our first healing item. Now we just need to call this function to assign our item choice to our item reference. So in our start method, let's just put item equals assign item and pass in our item drop enumerator. Now let's set up how our player will pick up our item. So let's create a new public void function called addItem. And let's pass in a player script. So we want to check our player's item list and see if they already have the item, and if they do, we want to increase the stack count, and if they don't, we want to add it to their list. To do this, let's again use a for each loop that cycles through everything in the player's item list and check if the name of the item in the list matches the name of the item we want to give to the player. If it does, we will increase the stacks by 1 and use return to exit our function. But if this for each loop completes and never calls return, our function will continue down, and since we know our function reaches this point if there is no matching name, we can add our item to our player's item list. Now, depending on how you want your player to pick up new items, you may want to do this differently, but let's create a simple walkover script. So let's call a simple onTrigger function that checks if our trigger collides with the player. And if it does, let's get their player script, and then let's call our addItem function and pass in that player script. Now whenever our player touches this item, it will be added to their inventory. Let's also remember to get rid of that start method code that was giving our player an item on start, and let's create an item to pick up. Okay, now let's create a sphere and reset its position. Let's change its collider to be much larger and swap it over to a trigger, and then let's add our item pickup script. We can use our dropdown to make this item whatever we would like. Let's use our healing item to start with, and then let's also add a rigid body component to make sure our onTrigger enter function activates correctly. Let's also uncheck gravity. Let's rename our item, and then let's put it in our prefabs folder. Now back in our item pickup inspector, let's use our drop-down menu to switch it over to our fire damage item. Rename our item to fire damage item, and then place it in the prefabs folder and save it as a new prefab. And then let's repeat this process for our healing area item. Now if we place our items in our scene, we can now pick them up by walking over them. Awesome. Now that we have everything set up, the workflow for creating a new item is: create a new method in our abstract class if it's needed, create a new item, and if a new method was created, create a new function to call our new method and add a function call in the appropriate place. And if we want to add our new item to our item pickup, add our new item to our item pickup enumerator, add our new enumerator to our switch statement, and finally use our dropdown to create a new item pickup prefab. And that's that. I hope this video was helpful. If it was, please consider giving me a like down below. It really helps me out. And if you want to see more videos from me in the future, you know, subscribe and do all that good stuff. If you have any questions or comments, please leave me a comment down below and I will hopefully get that answered for you. Or if you just want to shout at me for whatever reason. And yeah, thanks for watching.